All right, it's noon. It's time to start, I guess. Welcome to this session. I'm so glad you're all here. We're going to talk about build it once for both. So we're going to talk about an application that will run on Windows Phone and on Windows 8. I'm going to give you some tricks and tricks and tips and other things, and things like thinking about architecture. What do you need to think about? Now, we ran this same session a couple of weeks ago at TechEd US in New Orleans, and we had some very cool demo with some, additional hardware. Unfortunately, that hardware didn't make it to ship here. So instead I wrote an emulator, but the idea is going to be the same. And as a special treat, I'm going to give you some more, ideas and demos of some other applications that you can think about for running, both on Windows Phone and Windows 8. My name is Maarten Struijs. My funny accent is from the Netherlands, actually. I'm working at Microsoft as a partner technology manager for Windows Embedded, which these days has little to do with Windows Phone, actually. But my passion is Windows Phone, so I'm really, really happy that I'm, able to talk to you about some, Windows Phone designer aspects. It's going to be a full talk for sure. We're going to, probably spend the next 75 minutes with me talking. But hey, if you can stand it, at the end of this session, like with every Windows Phone session, there is at least a chance to win a phone. So it's just a matter of, listening in and stuff like that. This slide, if you have done more Windows Phone sessions this week already, you've seen this probably gone by already. Windows Phone is a right choice for business. It's also a phone that, is a personal device. You can perfectly run Office applications on it. It connects beautifully to the sky. And one of the things that I like on this slide basically is that if you look at the left-hand side, that small picture there, that's kind of the focus that we're going to have today, because we're going to talk about developing applications for both. One of the things when we were releasing Windows Phone 7, we were based on the Windows CE operating system and Windows 7, and which is a completely different operating system from big Windows. So it was, kind of exciting when Windows Phone 8 was released that at least we now share a lot of common functionality, like a lot of kernel, Windows runtime functionality between Windows and Windows Phone, which also makes it possible, or at least way easier, to share code between Windows Phone and Windows 8. Now, there's still different devices with different purposes, but if you can develop an application that you only have to write once, and if you can target multiple devices with multiple form factors, with multiple markets, it means that you just can make more money if you are, like an independent software vendor. On the other hand, if you're developing for the enterprise, it makes sense as well. If you can develop one application, run on multiple devices, and if people want to bring their own device to work, well, you just have less work, less maintenance, less development time. I want to take it one step beyond if we have time, because I also want to, spend some time talking about difference between Win32 applications, traditional applications that are running on Windows 7, but also on Windows 8, and Windows Store applications with that null paradigm that, the application is submitted to us, we certify the application, and and an end user installs it from the Windows Store, or in the enterprise we have other mechanisms. And I want to show you the difference in application behavior between those two if we have time, but I make sure that, if we don't have time, I'm going to hurry up. And the good news is also, we have a lunch break after this session, so I might just steal 5 minutes from your lunchtime. I'm totally fine with that. I hope that you will be too. Now, let's just talk about, the whole thing is the app is dead, right? I mean, there's nothing like an app anymore. It's not important. So I guess I just gave you back 75 minutes right now, because if the app is dead, we don't need to talk about the app, let alone on Windows Phone or Windows 8. But what I mean with that is something completely different. It's not that we are not using applications anymore, but what we're thinking about is way more, we're thinking in platforms. It's like we're not thinking about an individual application, but we're thinking about, hey, I have a phone that needs to run this and this functionality, and I want to have that functionality also on Windows 8. How do I do that? How do I achieve that? So instead of thinking about individual apps, we're thinking about platforms, and we're thinking about a way how we can utilize those platforms to the best. And In order to do that, you want to build across devices, and there are several ways in which you can build across devices. And if you think about the way Windows Phone and Windows 8 are actually, created, sharing the same runtime, the Windows runtime. So the Windows and the kernel is for a big part shared between Windows Phone and Windows 8. And you can see like, hey, they go together like bread and butter or milk and cookies. So they are best friends forever. Windows Phone and Windows 8 are liking each other a lot. And that really helps us in order to share applications between those two different operating systems. Now, they're not the same. It's not like we are running on Windows Phone, we are not running an identical operating system that Windows 8 is running. Because Windows 8 has specific functionality, Windows Phone 8 has specific functionality, but there is a common layer in there, and that is the Windows runtime, basically the kernel of the system. Thanks to the fact that we have that common functionality, Windows Phone 8 now has the possibility of, way better security than we had in Windows Phone 7.5. We just brought a lot of features that Windows already has to the phone. So for instance, security using BitLocker and stuff like that. We kind of got it for free inside the phone because we are running Windows 8 bits right now. Things that are in common are the networking stack, everything around sensors, everything around near field communication, in-app purchase, so the whole mechanism, if you want to, sell functionality inside your application. Let's say you have a game, and each time a user reaches a certain level, you can just, suggest to the user to actually buy additional levels. The whole mechanism in order to do that is exactly the same. Location awareness is the same. We share the file system. That's the reason why we also have BitLocker available, for instance. We also share the core application model and things like threading. So if you have a multi-threading application, its behavior will be identical on Windows Phone and on Windows 8. And if I'm saying Windows Phone right now, of course I mean Windows Phone 8. I'm just, abbreviating that because it's, the latest released version. The fact that threading is the same also means as a developer that you need to realize like, hey, the phone needs to be fast and fluid. So every operation that's going to take longer than approximately 50 milliseconds will actually run asynchronously. You don't have to do much for that yourself. It will just happen because the operating system supports that. Now, talking about building across devices. I love JavaScript and HTML5. As a developer, I just simply love JavaScript because I can, use this scripting language and target multiple devices. So really, I love JavaScript. And of course, it's supported on the phone. And this is me working with JavaScript for 5 seconds. I really love it, right? I mean, I'm a C# developer, and I'm always surprised about the power of JavaScript. I don't want to make it ridiculous. I want to make myself ridiculous here, because this is really how I feel. It's like, gosh, this is complex for me. But on the other hand, it's extremely powerful. So I shouldn't be unhappy, or I shouldn't be, like in a bad mood or whatever, developing using JavaScript. Because if you look at Microsoft, us as a company, for our devices, we really love JavaScript. And we really love HTML5. And there's many sessions also here at TechEd that actually covering HTML5, JavaScript. And it is true that, like taking this approach, you can definitely develop for multi-different platforms. Thanks to the fact that we have WinJS for Windows 8, you can run JavaScript and HTML5 natively with native applications inside a Windows 8 device. On a tablet, I can run native applications that are written in HTML5. Now, on the other hand, on the phone, that's a little bit different, because on the phone, you don't have that option to develop native applications written in JavaScript and HTML5. But what you do have on the phone is exactly an identical version of Internet Explorer, IE 10. So Windows 8 and Windows Phone 8 have exactly the same identical IE 10, which has great support for JavaScript and HTML5. So if you want to target multiple devices and you're already familiar with JavaScript and with HTML5, then a real true consideration would be like, hey, I'm going to take that approach, I'm going to run natively on Windows 8 hardware I can run my application natively, and on a Windows Phone device, I'm going to run that same application from inside a browser. And actually, if you look at Visual Studio, and if you start a new project, we have a project template that exactly fulfills that model, where you get, like a regular Windows Phone application with a startup page and blah, blah, blah. But immediately, the one and only control on that is an IE control in which your application can run perfectly. So that option is fully supported. And in order to show that, there's a little game out on Codeplex. That game is called Yeti Bowl. And Yeti Bowl shows an application, a sample application, written in HTML5 plus JavaScript, and it runs on multiple platforms. Now, I'm not going to show how the source code is built up, but all that source code is actually available from that URL there, so you can, like download it yourself. It's completely for free. You can take a look at it. But I want to show you that this is running inside Windows Phone on a Windows 8 device, but also inside browsers. So let me just change to my development machine here. And in order to do that, let me find my game. Should be here. And let's just run it in a browser. So I'm just starting that game here right now. It's a silly little game. It doesn't matter, like what the functionality is, but I can, kind of drop bombs on these people there. And I have touch capabilities. I'm running in IE10 here. And performance is pretty good. This is entirely written in JavaScript, and the markup is in HTML5. Cool. There's even sound there. If you could hear that, I could bump that up a little bit maybe. And try it again. And there we go again, hopefully. Let's see. There we go. I'm not good at playing games, as you can see. You'll hear some, like a little bit of sound there. Boom. Fully supported from inside the browser. Now, since this is inside a browser, you can go across multiple platforms, but also across multiple browsers, of course. So what I can do is also take this same game and start it in another browser. And actually, I, use this particular browser for one purpose, and that's to show that, hey, this game is actually running. So this is another browser, same game. The only thing what I'm missing is I don't have touch. You can see that, like I'm trying to do touch, but that's not possible. So I need to use my mouse here because this particular browser doesn't support touch. But the game is exactly the same. The experience of the user is exactly the same. So inside a browser, you can, of course, run web applications, and those web applications are similar to each other. But now, how about using or running this same application inside Windows 8? Well, I can do that too. So here I have a Windows 8 solution. So I'm going to start Visual Studio right now. And this is a perfect way. So again, you can see the source code. We can see how this is built, what the difference are between a Windows Phone version, a browser version, and a native version. And if I'm running this version natively on my local machine, you will see something different. For starters, I have a nice start screen here because I now know that I'm running natively. And the UI is a little bit, let's say it's a little bit more interesting to see. But for the rest, we have the same functionality. And it's exactly the same code that is actually running here. So the game is the same, the behavior of the game is the same, but the UI looks a little bit more interesting thanks to the fact that we are running natively, also making use of native acceleration for graphics. So that's cool. And now I can take that same game, and if I take that same game and now I'm going to go to a Windows Phone version of it, and if you take a look at the source code, you will see that about, like 95% of that source code is actually shared. I just have different, what's it called? I just have different solutions because of the fact that now I need to again run inside a browser on a Windows Phone. So if I'm deploying my application now to a Windows Phone, I'm going to run the application. You will see the UI looks very familiar. There the game starts again. I'm running inside the emulator here, but the emulator is completely touch aware, so I can run that same game with exactly the same experience also on a phone. And I wrote the game engine only once in JavaScript. So that's a great way to actually, share code and do multi-platform development. But as I said to you, I'm not a JavaScript, developer. I'm not an HTML5 developer. My background is from C++ and C#. So I want to see and explore if there are possibilities to actually work with, a different programming paradigm to share code between Windows 8 and Windows Phone 8. So again, we're going to build across devices, but we're going to take another approach, not like a web application type of application, but I'm going to go native on the phone or on a Windows 8 tablet, let's say. Since we share that same functionality, it means that at least in those areas that I already mentioned, that we can reuse code very easy. Now at the same time, of course, a phone has a particular form factor. And if you look at my laptop or a tablet machine, it has a completely different form factor. So in the UI, we're definitely going to have some challenges if we want to, have one application that will run on multiple platforms. So that's a thing to at least be aware of. However, thanks to the fact that Windows Phone 8 supports native code, what we can do is make use of a lot of existing libraries, and those existing libraries allow you to again target multiple platforms. If we look specifically at Windows Phone and web applications, I wish I could say hey, Windows Phone is the only mobile platform around in the world, so if you develop applications, just target Windows Phone and you're good to go. I wish that was true, but I also need to be, living in reality. And then we know that, Windows Phone is a great platform, but there are other platforms that, have been around for a while. So as an application developer, you always have this challenge, which platforms, which mobile platforms, which phone platforms am I going to target? And guess what? Android is probably going to be one of those platforms that you're going to target because of a huge install base. So the way of making money is, kind of easy. iPhone, yeah, you probably want to target that too. A web application, why not? Thanks to, gaming engines, for instance, like Unity, written in C++, but with an interface on the upper end in either C# or JavaScript or Boo as another scripting language, you can use a gaming engine, write your entire game, including all the algorithms, making use of functionality inside Unity, and distributed it over different multiple mobile platforms. Now, I'm not going to talk about game development, let that be clear, but this is just an example of, hey, there are third-party products that make your life easier if you want to target multiple platforms. This platform is typically targeted for gaming development, but it's just a matter of, looking at functionality that's provided, and maybe also for an enterprise application, there might be either ideas or even pieces of functionality in a library like that you can reuse. For databases, it's kind of the same thing. We support SQLite. Well, SQLite is actually a database engine written in C++. Thanks to the fact that Windows Phone understands and can execute C++ code, we can, take a SQLite library and use that inside an application. That's already going more towards an enterprise approach. So there's different approaches, different opportunities that you can make use of. If you want to know more about that C++ thing that I was talking about, well, this is my hobby, as you can see. C++ is like hardcore development. So, and you can do everything, literally everything what you want to do. So in the afternoon, around 5 o'clock this afternoon, I'm going to give a talk specifically, zooming in on using C++ on Windows Phone. Because there are some, again, things that you need to know in order to use native code on a Windows Phone device. So if you want to go and see that particular application, that particular presentation, it's the 308 presentation at 5 o'clock in the afternoon here. Then we're going to go into native code. Now for this for this presentation, I'm going to stay with managed code, with C# code, but we're still going to build across devices. So this was an intro, and this is like, in this talk, it's ridiculous to have an intro of 20 minutes or something, with basically nothing happened except for me showing you guys a game. But I think it's important to have that intro and to really, you know, like show some of the challenges you will have if you are developing for multiple devices. One of the biggest challenges you will have, and one that I'm kind of covering a little bit, is that difference in screen size. I'm a phone developer, and the first time I tried to develop a Windows 8 tablet application, a modern style application, submitted to the store and blah, 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 it turned out for me it was extremely difficult to do that, because I'm thinking in, you know, like 480 by 800 pixels. So my first application kind of looked like I took this real estate, that screen size, kind of dumped it in the middle of a tablet, and the rest behind it was black or something. Now that's not the approach you should take, because you get, you know, like devastating results if people are evaluating your applications. So what really would help me is trying to not think about UI designs and take a designer to assist me to come up with a cool, appealing user interface, both for a phone and for a tablet. Because for me, it's extremely difficult to fill all those pixels. There's so many of them there on a tablet device. Now, if you are a PC or a tablet developer, I'm pretty sure you have the same thing. There's so little room there, you still want to fit a lot of information there, so you're going to make everything, you know, like very, very small. And with high-res devices, that's possible. But if your fonts are becoming too small, it's going to be harder and harder to read them, right? So one of the things that's most important if you want to develop for multiple devices is that you need to separate the user interface from the functionality. If in an ideal world there would be no connection between the user interface and the functionality you want to achieve at all, it would be very, very easy to replace one UI by another, leaving functionality unchanged, and in that way I could target multiple devices. So that's the mindset we're going to take for right now. So what I'm going to talk about is how can you achieve that loose coupling between user interfaces and the rest of the functionality, but also give some best practices there. I'm going to talk a little bit about this cool thing being the portable class libraries, what you can do with it and where there are some limitations. We're going to talk about code sharing in general. What can you do? What should you do? What should you not do? And I'm also going to give some guidelines around user interface design. I'm not a designer, but there are some things that are pretty obvious if you take a look at the controls that we have for tablet machines and for Windows Phone devices. So let's just talk about MVVM very short. Who's familiar with MVVM? Okay, so we can keep that very short actually. Because basically what MVVM is all about is separating design from presentation. That's the most important reason why there is something like MVVM. And the cool part is, if you take a look at our XAML-based applications, they have perfect support for that, through data binding, command binding, where the coupling between logic and presentation is almost automated, which is really, really nice. So MVVM, model, view model as an architectural model, is really fitting perfectly for Windows Phone development and for Windows 8 development. It just stimulates code reuse. And if you have some logic, some functionality, and if your presentation is completely separated, it could also mean that I can have different types of different ways of presenting information to the user, also on different form factors of devices. Another thing that MVVM makes really easy is testing of functionality. Because usually, you know, like in the past, what we were always kind of explaining to people was like, hey, we have this great new thing called WPF or something. And you just drag and drop some controls onto onto a design surface. Then you double click and you get an on-click event handler. And inside that event handler, you write some code, and that code will contain your application logic. That model works, you know, like because you get something up and running pretty fast. But at the same time, testing that type of code is kind of hard, because who's going to fire that event handler? Typically a user. So automated testing It's not impossible, but you need to have, like a separate test harness. You need to think about, like how am I gonna actually, like cause those events to happen. If you take the MVVM approach, take that as an architectural pattern, what you have achieved is a complete uncoupling of commands and the trigger to activate that command. So a command is a standalone method. That standalone method can be called independent of anything else, which invites for unit testing and automated testing. Now, there are several things that are important if you're taking, like the MVVM approach. It's not like I am not a purist, there are people who think like, like in the model, you should only have, like data, and there should be no transformation on that data or something. I am more like in an approach like, hey, if you need to do something, if it makes sense to change something in a model, if you need to, let's say that I have a temperature that I'm storing as a property, a public property, and I'm storing that in Kelvin, but I need centigrade or something. I am not against, like doing a little calculation inside a model. Other people are more, pure about using MVVM and say like, hey, you shouldn't do that because it, like kind of hurts maintainability. My approach is be pragmatic, especially because we are, like developing applications for devices that are kind of still, let's say, limited in resources, even though they have dual core and like in the future quad core processors with 16 gigabyte of memory or something. But still, if you compare this to a modern tablet or to a desktop device, these things are going to lose it from a resource point of view. If I'm doing a lot of things to actually assemble my results that I need to present in the end to a user, and if I need to do a lot of, like duplicate method calling because I want to live to the, like real spirit of an architecture like MVVM, I might just use too much processing power on my device. That in itself could influence performance, but what's even worse, and that's why I'm always worried about doing too much on the phone, it will influence battery life. And there's one thing, and only one thing in my opinion, that we as developers have a responsibility in, and that's think about battery life. If you duplicate code because of the fact that you want to follow a design pattern, well, I would rather not duplicate that code and save a little bit of battery power, because my end user at the end of the day might use that, maybe to call 112 in an emergency situation or something. So that's an important thing that you continuously have to ask yourself, like, how am I going to fit, like my MVVM-based design into something pragmatic as well that I can use to, like create applications that are maintainable, but at the same time are not duplicating too much code. So MVVM stands for View, Model, View Model. And the idea is that the model contains, like data basically. So what you will see in the model typically is there might be a connection to a database, but typically there's a class with a number of public properties, and those properties can be, like retrieved, and you can set new values to that properties. That's what the model is all about. I was running a little bit out of sync with my slide, I guess. The view model is the layer inside that architecture where things really happen. So the view model is responsible for all the application logic. If I want to make, like some calls to some device outside of my own Windows Phone or something, I could wrap that around the servers, and I could put my service calls inside that view model as well. Data management. If I'm, like filling my model with information, how am I going to do that? Am I going to retrieve that information from a SQLite database, or am I going to, like retrieve it from an XML-based file somewhere in my file system? All that kind of functionality will live in the view model. And the model feeds the view model with information through usually a set of public properties. Then the next thing we have is a view. The view is the presentation of information in the model typically. Now there can also be, like additional information that can be calculated inside the view model as a result of information inside that model. If the view model has information that changes, then the view is informed about that through a data binding. That data binding, something which is essential for that, is we need to know whether or not properties inside the view model have changed. And for that, there's an interface available. I notify property changed. Each time that I notify property changed interface is fired, there will be a message generated that can inform the view, like, hey, this particular property on which you subscribed has a different value, just update the value. And that's a two-way direction, so you can specify, like, hey, if the user changes that value, then my view model needs to know about it. And the other thing what we can do is send commands from the view to the view model. If a user clicks a button, instead of immediately running the code behind in a code behind file, rather what we will do is send a message to the view model. That message indicates, like, hey, the user clicked this and this and this button. Do you have a method that should be executed when that command message is received? So it's entirely loosely coupled. And that's the idea that works pretty good for a build for both structure. Now, we can take this one step further by making use of portable class libraries. Who's heard of portable class libraries? Okay, about the same amount. So portable class libraries are kind of a new thing in which we have functionality that available that can be shared amongst multiple different devices. And you can go as far as, like, I can target a .NET application, a Windows 8 store application, a Windows Phone application, Xbox. That's all possible. The thing is, you always have the common denominator of functionality. So the smallest amount of functionality that is available on multiple devices will be available and accessible through a portable class library, but especially if you add Xbox as another target, you will see that the amount of functionality available in your portable class library will be limited because of the fact that Xbox has a little bit limited capabilities compared to the full .NET framework or compared to Windows 8. But typically, a model is something that fits perfectly in a portable class library amongst that can be shared between Windows 8 and Windows Phone 8. View models might be partly candidates of, like exposing through a portable class library. And it really depends on the functionality you need inside a view model, whether or not you're going to continue with that. One of the things that a portable class library does not support, because it's fundamentally different on multiple devices, is, for instance, accessing file access. So if I want to store some data, I need to go outside the portable class library. If I need to store some data inside my view model, maybe some temporary data to keep some status or something, then I cannot use a portable class library to expose that functionality. But instead I'm gonna, like maybe have a abstract view model that defines an interface, store information, and have an implementation outside my portable class library, but still from my view model, that actually implements that piece of functionality to store a particular file in a storage medium. And then, on top of that, I have some presentation layer with probably a number of converters. So for Windows 8, I might have some converters in order to show information properly in a user interface. Let's say I have a color. A color is typically represented by an RGB value and maybe, like a Y for clarity or something. But if I want to represent a color inside a user interface, I typically need a brush. That brush takes an RGB value, but the end result will be that I will get a solid brush back. A converter is, like a mechanism in which you can take particular values, translate them to something else, and that something else is used for presentation. And with Windows Phone 8 and Windows 8, between those two, you might need different converters. There's also something which is completely different between Windows Phone 8 and Windows 8, and that's navigation. Windows Phone 8 is really based on a page model with multiple pages containing information, and each page containing, like a limited amount of information. Because of the fact that Windows 8 has, usually more real estate, the navigation model is way more of a scrolling and horizontal scrolling through a lot of information without that page concept. You can implement it, but typically you're not. So navigation is something you need to be aware of and you need to understand in order to create a user interface that is, like suitable for Windows Phone 8. All these things sound theoretical right now, so it's, it's probably about time that we're going to show a little example, and that little example hopefully clarifies a lot of the things that I'm talking about. But if you take this, like this approach, making use of a portable class library, that's typically functionality that's in your model, and maybe something in your view model being, like an abstract maybe class that represents a view model. Inside my view model, I have a real implementation of functionality that needs to be there in order to feed my view. And my view in the end is, like the layer that is presenting information to the user. Typically in a Windows Phone and Windows 8 situation, the model and the view model can be largely shared. There are some situations where there might be differences, but those are the areas where you can share code. If you take a look at the view, that's the area where you are definitely going to design something else for those two devices. Now, this was the moment where that demo would actually show up, where we had an additional piece of hardware. And that piece of hardware is the Philips Hue. I don't know who's familiar with that particular type of device. Okay, not that many people. It's basically, it's a, it's a LED light bulb that can be programmed through Wi-Fi. So what I have here, what I'm showing here is a Wi-Fi bridge. And that Wi-Fi bridge can be used to control a number of LEDs. And what you can do is set the color, set the clarity of those lights. And they provide a particular, application that you can run from your phone or whatever that sets the mood. So if I'm waking up in the morning, I don't want to have the lights too bright, so I can have a program that automatically have, like a nice, let's say, dimmed type of light and a pleasant color for me to wake up. And when, it's getting later, then that light can be adjusted, etc. Now, this is an open programming model, so there's also a possibility for us to write applications for that. That was our goal. And we had that stuff in the United States. And a couple of months ago, I had the privilege to talk to the people who actually invented this stuff. And they said, we are overwhelmed by the success of it. We thought that we would sell, like a couple of thousand devices in the first quarter when it came to market. They were sold out in the first 2 days that stuff came to the market. They were selling it through, like some high-end store. And then, for them, the challenge was like, hey, we need to catch up with production. And I found that out because I couldn't get that stuff shipped from the United States. So actually, I asked them, I asked the people who developed that, I said, can you borrow me one of those, like setups with 3 lamps and stuff like that? And they're like, no. Can I buy it then? And they're like, yes. Can I have it next week? No, but 4 months from now you can, which is kind of useless. So I couldn't use this actually, which is too bad because the application was written like that. So I cannot show that. So yeah, if you evaluate this session, don't mention that I couldn't show that. That would be hurtful for me, of course. But instead, what I did last night was I wrote an emulator to actually emulate this situation. I'm making use of an Azure mobile service for that, and I'm just setting RGB values. Because our demo is as follows. Let me just show it right away. Well, in order to do that, I probably need to change to here. And what I have here, let me make sure that my mouse is alive. I'm just going to terminate this Yeti bowl. It's not interesting anymore. And what I'm having here is my Hue application. I'm just going to run it inside the emulator. Now, I'm not sure with the network. I had some problems with the network earlier, so it might give an error message that says, there it goes. So what it shows is I have 3 lights actually, and it shows the color setting of this first light here. And, like with some lamp here, we would have seen that. And what I can do is I can change individual RGB values, and immediately you see some feedback in that kind of light lamp icon. I have that same application as a Windows 8 application. Let me start that application. Already installed it here. There we go. This is the same application. But since I have more real estate here, I can show those three lights together. Now what I'm going to do is I'm going to snap that there. Then I'm going to go back to my desktop. And I'm going to take a look at my emulator here. And what you will see is the first light is controlled by that Windows Phone right now. So if I'm going to make this a little more extreme, I'm going to go back there. What you will see is that the Windows 8 machine follows that light. So it's not just that I'm not just controlling the lights, but also I'm talking, those lights can talk back to devices and send updates to devices. So that's the scenario. If I take another light bulb, should be able to do the same thing. And you see there's a little delay because after a while we are interrogating the lights every now and then. Again, my implementation now is different. I'm just pushing that information to an Azure mobile service, and whenever there's a change, I'm going to push that back to all the devices who subscribe to that. So I can also do that the other way around. So if I'm taking this one, and we are at light 2 right now. And if I'm adding some red there, I'm going to go to yellow. And after a while, you see that that device changed to yellow as well. Now, the idea of this application is, hey, since it's Windows Phone 8 and it's Windows 8, I want to try and share as much code as possible between those two different devices. From a functionality point of view, it's not that difficult. I have 3 lights. I need to control the lights and I need to read the light status. Controlling the lights goes through RGB values and a brightness value. That's basically all there is. From a UI point of view, you already saw that it's completely different what I'm showing there. So we're going to take a little look at some code as well later on. But this is the scenario. Now, what I want to do is, or what I did was develop that application with as much reusability as possible in mind. So I'm making use of portable class libraries. I'm making use of a view model that separates the view from the logic, the application logic. Exactly that same model there. The UI is completely different, simply because of the fact that I just don't have enough real estate on that little phone there to show all those light bulbs. I could have done it. I mean, you could have done 3 next to each other, but then using those sliders to actually with a finger control the user interface would not be the best experience anymore. So that's the reason why the UI is completely different. Some things, however, are exactly the same. The way to send information to those light bulbs, the way to retrieve information from those light bulbs to ask them what color they're currently showing. So those are things that are available in update light command and get lights command. And the model, the data that I need to store in order to, use this application is kind of the same too, because that model basically represents one single light. That light has an R value, a G value, a RGB value, and a brightness value. So very simple properties. And I need some communication to talk to that light bulb. And there I found out that I had another added benefit because I'm making use of a service there. A service is nothing more or less than a piece of functionality that is exposed through an interface. So I defined an IU interface, and that interface has entries, method entries, to set a R value, a G value, a B value, etc., and to retrieve that information. Thanks to the fact that that service is exposed through an interface, for me it was very easy to actually replace a physical implementation to communicate to those lights with a emulator representation communicated to an Azure service. Because the interface remains untouched, so I just needed to provide one single other implementation, and it was good to go and actually show you this demo, be it a little bit more restricted. So thinking in services is always a nice thing as well. If I translate, again, my application into an MVVM type of approach, then the presentation part, the green part, is definitely some user interface with some controls. The user interface is updated through data binding. The controls are passing information back through command binding. I have a view model. That view model contains commands to update lights, to get lights, and it hosts a Hue service to physically communicate with either a light bulb or with an Azure mobile service. And I have a model. That model just has 3 different instances of lights. Now there you can see that this is a demo application because I'm only using 3 instances of lights, physically repeating. So I have a light 1, light 2, light 3. A more software engineering type of approach would have done that a little bit nicer and cleaner, but I just wanted to, keep things as simple as possible. If the Hue control view model noticed that some light has changed its color or its intensity, then through data binding, the user interface will be updated. If at the same time a user touches those sliders, then through command lighting, we will update the physical light bulb. And that communicates, of course, to the Hue service. The Hue service then actually sets a particular value to one of those light bulbs, and we're going to ask if that setting was successful. So there's also some error handling in there. And that's basically the whole, approach that I'm taking for this simple application. If we have a new value, updated value for the lights, then I'm going to maintain my model as well. The reason to do that is the next time I'm starting this application, I want to make sure that the lights appear in exactly the same situation as they were when I left my application. So I'm maintaining state. Now, portable class libraries, again, it's a library, it's a fully supported Visual Studio model in which you have one source, one single project, one binary that can run on multiple platforms. And we have a lot of these libraries right now as Microsoft in beta version. For instance, there's an HTTP portable class library that kind of abstracts away the tiny differences between HTTP clients on either Windows 8 or Windows Phone 8. So making use of that particular HTTP library makes a lot of sense. And actually, I'm using it inside my application right now. And that's just an example. There are many, many more of those. And if you look in MSDN, you can find them. So if we take a look at my view model, what is inside my view model? There's an instance of a light 3 times because I have an installation where I had 3 different light bulbs. Those instances of those lights maintain their status, the R value, G value, B value, and the brightness value. There are commands to update those lights, and they're communicating with a server instance. So that's the functionality inside my view model. And I split that view model a little bit up in an abstract view model or a limited view model and a particular implementation for either phone or Windows 8. Portable class libraries, the reason why I split up my view model, for instance, is that we have some limitations that file I/O is not supported in portable class libraries because there's too many differences still between those different platforms. There's also platform-specific functionality, like for instance, if I want to make a phone call, that's possible on a Windows Phone 8. It's not possible on a tablet running Windows 8. So that type of functionality will also not be available through a portable class library. There's no timing functionality, so a dispatch timer is not available. The reason is that the hardware running a Windows Phone and the hardware running a tablet or a desktop machine differs completely from each other, and a timer, a hardware timer, you need to know the exact implementation of that. They differ too much to put them into a portable class library. It would be too much, the abstraction layer would be too high for high resolution timing functions to justify that. So that's specific per platform. Now, in order to share as much functionality as possible, the approach is that, hey, I have a hue control view model that exists in a portable class library, and I derive from that hue control view model just using object-oriented techniques and create a hue client view model specific for Windows Phone and specific for Windows 8. In that way, I can share as much code as possible, yet have the possibility to add specific functionality for a specific target. Those specifics are basically the implementation of the getLights command and store information on the device. GetLights command is specific because of the fact that I needed to do something different in my Windows Phone emulator, or sorry, in my emulator for the hue lights. If we would have run on physical hardware, that getLights command would have been the same for Windows 8 and Windows Phone 8 because of the fact that there is this HTTP client, which is a portable class library. But I could not use that, unfortunately, right now. Storage is also different because file I/O is different on Windows Phone and on Windows 8 right now. So, this is just, like more or less a repeat of what we already had. What I'm achieving, though, is I have a portable class library. The code between, the code from the portable class library, the binary of the portable class library is shared between Windows Phone and Windows 8. And that view model that derives from my basic view model that's implemented in the gray there, I'm using that. I'm still trying to reuse as much code as possible there. I'm doing that by using a Visual Studio trick, by instead of creating a new source file, I'm linking to another source file. I'm going to show that in a short demo. Then, if I have specific functionality for Windows Phone 8 or for Windows 8, I don't mind using some conditional compilation. So, for instance, using a timer is a little bit different inside Windows Phone 8 and inside Windows 8. In Windows 8, everything is kind of generic. So if I have a tick that expires, I get, like a callback. And that callback contains an object being a sender and an object having some arguments. In Windows Phone 8, and that's still some history from Windows Phone 7 actually, we have a sender, but we have event arguments that are passed, and that event argument parameter is actually basically 0, but the signature of the method is different. That's the reason why I'm using conditional compilation there. Same is true for intervals. Intervals, a tick on Windows Phone is different from a tick on Windows 8, so that's the reason again to use some conditional compilation. But with that, hopefully my source code is, like as much common as possible. I'm using data binding and command binding to completely uncouple the user interface from presentation. I'm going to show all this to you like in real code. And that hopefully, like with that, what we can achieve is one source code base for the most of our functionality with a little bit of conditional compilation. So let's take a look at that source implementation. I'm going to just quit that application, go full screen here, and I'm going to stop debugging. And what you basically will see is my generic approach here. So what I'm having is a portable class library, a Windows 8 specific piece of functionality, and a Windows Phone specific piece of functionality. In my portable class library, I have my model. Inside that model, I have a light and some more functionality. That light has a number of properties and it has a number of states. So a light can be on. A light has a brightness. A light has a value for red, green, and blue. And the implementation of those things is very simple. I have a private member, an integer, and I have a public property of type integer. I have a getter and a setter, and each time I'm setting a new value, I'm also informing the system that this particular property has been changed. This causes an application or a user interface that is data bound to this property inside this light bulb from my model to be updated automatically whenever that value changes. I also have a view model, and in my view model I am controlling basically my hue, so my light bulbs. I did comment it out instead of using, like a status like am I running on the emulator on physical hardware right now. So that code might look a little bit messy there. But basically what I have is an implementation, an instantiation of 3 different hue lights, and those hue lights have different values. Each time a hue light changes, again through data binding, I can update the entire user interface. I also have some services, and my service is basically an abstract class, and this abstract class is used to communicate to physical hardware or to an emulator. So this is the way you implement on servers. This hue service has, because it's an abstract class, it doesn't have an implementation for particular functionality, but it has all the entry points. So if I'm using this class inside an implementation inside my view model, I am forced to come up with functionality for all those method entries. In that way, I can make something which is kind of generalized, like this abstract class. I can make it specific for a particular device. In that particular device, which is, for instance, my Windows Phone device, I again have a view model. That view model has a view client method. This one implements that base view model that is available in my portable class library and adding some additional functionality to it. Here I'm also going to make a real instantiation of my Hue emulator service, which derives from that same interface that I showed you before. So what you also will see is that I have functionality here to update my light and physically, in this situation, store that information on a cloud service. That would be different if I'm, like communicating to light bulbs. So that functionality, that implementation is different. If I take a look at my Windows 8 implementation, I also have a view model. And if you take a look at my view model and that view client model here, you can see that there's a little arrow here. That little arrow indicates like, hey, I have a link to a source file that is defined somewhere else in my solution. And that source file, it's very easy to actually do that. I can add, like new existing items. And let me go to some existing item here. It doesn't matter which one because I'm not going to do it anyway. And instead of adding it, what I can do is add something as a link. Then there's only one physical existence of that particular file available. Let me cancel that. And you can see that immediately you get feedback if I have that document already opened in another project. So I had that opened for my Windows Phone project right now. This is a link to that same document. So I cannot open that in my solution or in my project for Windows 8. In order to do that, I would just have to close down this one and then open it again, but then for Windows 8. And then I should be good to go. Same thing, the only thing is that I now have different conditional compilations. You can see that already. So my environment variable is now set to NFX core instead of Windows Phone. If I would open that same that same source file in Windows Phone, then you can see like, hey, now Windows Phone is defined and NetFX core is not defined, which is a really neat way to see which code is executed if you're making use of links. And the real cool part right now is also that, hey, if I want to change something in my presentation, let's say in my Windows 8 representation, so let me go back quickly to that Windows 8 implementation of my Hue emulator. It looks like this. So the light header is kind of white. Now if I want to change something here through data binding, which is very, very powerful, I can do that very, very easy. So I'm going to terminate here. I'm going to go back to Visual Studio. I'm going to open my view, which is actually here. So that's my main XAML. Could have done that a little bit nicer. What I can do now is go to one of those light bulb representations, and it has a data binding for this hue light, and I'm using a converter to actually bind the value of a hue light, which is an RGB value plus brightness, to a color. I'm taking that converter and that value of that hue light, and I can, for instance, go to this light 1 text block, and instead of having a fixed foreground, what I can do is change that to make use of binding. Now if we're going to run that same application again, so I'm just going to start a new instance here. There we go. And what you see immediately is like now that text up there is following that same color pattern. So without recompiling things, without touching too much code, but by changing my binding, come on. It had some trouble communicating to the web service right now. That's too bad. Anyway, you could see already that that changed. So that's also proof kind of that we have complete separation between logic and presentation of that logic. Let's see if we are there now. Okay, so now it comes back temporarily. It's following, but then it says, okay, this time I got the web service there. So I can, like change this one here. Should get the same result. Boom. And we are yellow. Okay, let me go back to the slide deck real quick. Let's see, because there are a few more things that we need to talk about. So what I showed is indeed that, I showed data binding. The same thing is, and actually this is that data binding. What's important is also that it's going both ways. So if I change the light from another device, on the Windows Phone it will be updated. If I change on my Windows Phone the light, the tablet will be updated, or stuff like that. As an example of command binding, I need to rush a little bit because there's another important thing that I want to cover with you guys. So my XAML is kind of basically the same inside Windows Phone and Windows 8. The difference is the way command binding works. So let me go back here. If that's working. Funny. Using Windows Phone 8, I could use command binding inside XAML. What I'm doing for my Windows 8 application is I am waiting until a different event is set, an on-pointer exited event is set, and then I'm using code behind a little bit to fire that command. The reason to do that is that the behavior of a Windows 8 tablet, if I'm using that slider, I get bombarded by changes. And I don't want to send continuous information to my light, because typically what you want to do is change this value to this point. Then I'm releasing my finger, and only then I need to transmit that value to my hue lights or to my emulator. So this is just an optimization to get a little less traffic either over the wire or inside my device, because also a tablet is a battery-fed device. So there I'm also want to be careful with batteries. I just explained that. So now there are some big differences between Windows 8 and Windows Phone 8, and they have mainly to do with form factors of the device. A Windows Phone 8 device is typically a device that is operated in portrait mode. For games we use it in landscape, but the typical form factor is used in portrait mode. A tablet is always typically used in landscape mode. My only exception is if I'm reading a newspaper on a tablet, then I'm turning it around in portrait, but usually, and most applications, are most pleasant to use in portrait mode. It also means that since we have more information available on a tablet, we can just, like show those 3 light bulbs here, and on a Windows Phone, I only can show 2 of them. But there are a number of controls that really help us getting that same, let's say, hi-fi experience on Windows Phone that you already are, like getting for free on Windows 8. One of the things is semantic zoom. If I would have a long list of information together, and that's basically, that long list could also have been my 3 light bulbs, then on Windows Phone, what I could use is something like a pivot. And that pivot allows me to, just quickly scroll from page to page. If I have a lot of information to show, a lot of unrelated information, typically in a grid type of control on a tablet form factor, then for a phone form factor, I have a long list selector, which basically represents that same information, sort of. And only if I click one of those things, then I get, like an expanded list for the letter P, for instance. So those kind of are, like complement each other as well as user interface controls. So platform-specific functionality is typically the user interface. There's a little bit of platform-specific functionality in my example where timers are involved and where data storage is involved, but the rest of the code in my view model and inside my model is exactly the same and shareable between those 2 different devices. And what I found out is it has all to do with thinking ahead about an application. For me, being a phone developer, it makes most sense to actually start with a Windows Phone implementation, with having a Windows 8 implementation in the back of my mind, and thinking about reusing code continuously. The reason why that model works for me is that Windows Phone has limited functionality compared to Windows 8. So I'm using more or less a subset of functionality, and Windows 8 would be a superset. It's kind of harder to remove information than to make use of additional information. So for me, it works to start with a Windows Phone and work to Windows 8. But I can imagine that if you would have more experience with Windows 8 or coming from a Windows 8 developer background to Windows Phone, that might work better for you. And there's no hard rule for that, I would say. There's also no hard rule for implementing that model view model architectural pattern. Again, I'm using it pragmatic. If you remember my functionality in that slider, I'm still using a little bit of code behind for Windows 8 because it just makes sense for me there. Because I didn't want to get bombarded with too many events coming from my view through command binding. But it's up to us as software developers to see what kind of choices we're making. Now, I'm not going to go to the takeaways yet because I want to show you one more thing for a few minutes. I don't have slides for that, but I think it's extremely important. And since yesterday when we had the welcome reception, I was talking to people at the Windows Phone booth, it actually became even more important, I think. Because there's one thing, and let me just start Visual Studio again, but with another solution. This is not Visual Studio, is it? No, not really. I'm going to go to some other solution here, and we're going to go to some application behavior. This is a project which has a very extremely simple user interface. It's making use of MVVM, but this one is way simpler. But what I started with is a WPF application. That WPF application, let me just run it. And then we're going to talk about it. So I'm just going to start it. It's an application that does some background processing. I can set a sleeping time. And then I can start. And what's going to happen is, in a while loop, I'm just continuously going to sleep for 200 milliseconds, wake up, and I'm going to check if I need to continue sleeping. I need to continue sleeping until I click that stop button. So in real life, this application represents maybe an image manipulation application where I have a color image and I make it black to white or something, like difficult, complex image processing. And if I'm stopping, what you will see is that, hey, I kind of, like I'm just an amateur software developer, so I have a plus or minus one issue there. I probably didn't start counting with 1 or with 0 or something. But what I'm doing if I'm stopping is I'm calculating the time from start to end. And I know that I have 200 milliseconds pause each time. So I know, theoretically, how many runs I would have run in a while loop, which is 164, and I had 163 actual runs. Plus or minus 1, I'm fine with that. This is the WPF application. It's making use of the .NET Framework 4.5. And just because I wanted to find out how easy it is to transform a Win32 application to a Windows Store application. Because that's a question that also, like many of my enterprise customers ask that question. Like, hey, we invested a lot of time and energy in this Win32 application that's running on Windows 7 or earlier versions of Windows. We like that paradigm of Windows 8 with modern style applications, especially if we have our own private store through which we can deploy those applications, being enterprise applications. But we want to reuse code. How easy is that? So I started playing with that. And one of the things I found out is that, hey, this is extremely easy to do. So if I'm just terminating this application, and let's take a quick look at some source code, then I'm going to only look at functionality. I have here some functionality inside a worker thread. That worker thread, since it's already it's a modern application in such that I'm making use of the .NET Framework 4.5. I developed it on Visual Studio 2012. So I'm making use of asynchronous behavior, the async stuff. But what's happening here is I have an async method. In that method, I'm continuously going to run until this is running Boolean variable is false. And that's happening when I click a stop button. My user interface is updated through data binding, so that those counters are updated there. So what I did was the following. I took exactly that same application. I even took the XAML. Sorry, this one. I even took this XAML. So I took the user interface, literally got all the XAML from this grid up to the end, and dumped that inside a Windows 8 application. That same XAML failed miserably. So when I dumped it in here, you can see that the application kind of looks the same, but it's definitely rendered differently. It failed on one area. The one area being this expected runs is hidden until I hit the stop button or something. I made it hidden in my original WPF application by setting a property invisible or something. And that is not available on Windows Phone modern applications, because there you have a visible and collapsed kind of property. Only 2 instead of 3 different values. That was the only issue there. The other thing I did was I just, like I showed earlier, in my application, I used a link to that worker. And I used a link to my view model and to some other command that I'm using, and to some converters. So literally, what I achieved here is 100% source code compatibility. If I take another look at that worker, but from inside this thing, you can see that, hey, it's still open there. Well, that makes sense. Let me close it. I'm going to go back here to my Windows 8 sample. And there's not even conditional compilation in here. Now this, of course, is a very simple example. So I talked, to some people. I said, hey, converting data or converting applications from Win32 to Windows Store applications is very, very easy. And I even showed it, in action. But there's one thing I did not realize, and that's something that is very important if you want to develop cross-platform, Oh, I have a Windows Phone implementation as well using exactly the same code. But you also need to think about behavior of applications. So we talked this morning about Windows Phone versus Windows 8. Now I'm talking about Win32 versus Windows 8 Store applications. There is a lot you can have in common, especially if you take that same architecture. But let me start the Windows 8 version of this application. I'm not going to start it from inside Visual Studio. There's a reason for that, because inside Visual Studio everything behaves as a Win32 application. But I'm going to start it as a modern application. I'm going to run it, set this to 200 milliseconds. I'm going to start. And it's running. Beautiful. If I'm stopping, expected runs, actual runs, same plus or minus. One issue, so everything is good, everything is the same. I'm going to start it again. And now, I'm going to go back to my desktop. I'm going to run that same WPF application. Just start it from the debugger. I'm going to do the same thing. So here is the application. I'm going to set 200 milliseconds. The reason why I set a relatively large value here is to, have my processor at least not too much occupied. Because, of course, even if I'm multi-threading, still the physical processor has to execute this code. And this is running happily. Now I go back to my modern application. I'm going to stop it. And then I realized this is kind of bad news. But if you think about it, a modern style application has full resources available to itself when it's running in the foreground. When it goes to the background, it will in fact be suspended after a couple of seconds. So you have some time to save state, and then it's going to be resumed when it's going back to the foreground. So if you would have, like an image processing application type of thing, or if you have a financial application that is, like running salaries or something, and it's doing that in the background, and if your boss would say like, hey, it would be cool to have a modern style application for that, you have to think about the behavior. If your application depends on background processing, it will be completely different being a modern style application or a Win32 application. Because if I'm going back to that Win32 application, if I'm stopping this one, what you will see is like, hey, it's not plus or minus 1, it's plus 5 or something right now. Well, that makes sense because I was doing some other things in the meantime. What I proved here is that Windows 8 is a real-time operating system, but not a hard real-time operating system. So I cannot, the behavior is not deterministic. The behavior is like, hey, if I have background processes running in a Win32 application, a traditional Windows application, that will continue in the background. If I take that same code and run it in a Windows Store application, that code will behave differently. So if somebody asks you like, hey, can I convert my existing applications to modern style applications? The answer should be like, yes, but let's talk about how your functionality should behave. Because I could still realize that by making use of some service that is doing that number crunching and then giving the results back. But my architecture of my application should have been a little bit different. This was the extra I wanted to share with you because of the fact that I didn't have cool light bulbs, otherwise we would have played with that. But I think this might even be more valuable. We're going one more time back to the slide deck, I think. Because the key takeaway points, as far as I'm concerned, is like, hey, it's perfectly possible to run on multiple devices. It's also perfectly possible to have your applications transferred from Win32 to modern style applications or Windows Store applications. But you need to plan ahead and you need to think about things. But be pragmatic. Don't go, like sitting for 3 months or something in a room to set up an architecture. Use MVVM in its spirit. Portable class libraries might help you a lot achieving things. Link to existing files in your solution if you want to share code. Don't hesitate to, use a little bit of conditional compilation, as long as you still understand what you're doing. That's probably the most important thing I like. Also, use modern object-oriented principles, where I had a base class with some derived class, an abstract class that forces me to come up with some implementation of some functionality that really helps limiting your amount of errors, but also getting a positive result to run on multiple devices. And focus on the things that you can share. So don't try to fit a, like a Windows tablet form factor user interface on a phone, but use controls particularly for that device. I think with that we are at the end of the time, so I thank you very much for your attention, and we have one more thing to do, I guess, right? So make sure you hand out your card, otherwise you miss an opportunity. And in the meantime, I hope that you have a fantastic, remainder of TechEd. Tonight, the country drinks. If you want to see C++, be here back at 5. I'll be around for some time for questions. Also, I'm going to be around at the phone booth for, the remainder of tomorrow and Friday if you want to have one-on-one conversations about these topics or anything else. Because we just want to have, you get as much out of this conference as possible. Please also fill out your eval forms. I would love to be back for TechEd Europe next year, but if you guys think like, hey, this was a waste of my time, tell it. If you think like, hey, this was cool, please tell it too. I'd rather have that one, but oh, lots of cards.